Assalamu alaikum everyone. Welcome to Mathematics with Shahab Yaqub. Let me just get started with the recording thing. And it goes over here. Assalamu alaikum everyone. Okay, that's a repetition. Hold for a second. Go to this cloud. Assalamu alaikum everyone. We are starting with the live session on S1 and let me share the screen first. So let me just double check one thing. This thing needs to be changed. I'm just checking something. TP link, this is all good. Okay, some technical error. I don't know what seems to be the problem. It's all good from here. Unless and until the screen is shared, I cannot get started with this. This thing is TP link, that is good. And then there is the share. There is this thing. I think it will work now, inshallah. Okay, all good, all set. So now in today's class, our focus is on probability. Our focus is on DRV. Majority of the focus will be on probability, and today is one session. Then on Sunday night, mark the date, mark the time. I think it will be more or less the same thing, around like 7:15, 7:30. We will get started with it. And that will be more of DRV, and that includes binomial, that includes geometric, and so on. So now the questions I have already selected so that we can conserve our time. So we are starting with probability now. And there will be a variety of questions. So my objective will be not only solving those questions, but kind of labeling them. That what exactly are those questions all about? So now this first question, let me highlight it. It says in a group of 30 teenagers, 13 of the 18 males watch this TV show that is called Cops Are Kids. So first of all, there are 30 teenagers and then 13 of the 18 males. So first of all, let me mark 18 males over here. And they are watching this particular show, which is called Cops Are Kids, and 3 of the 12 females. So there are 12 females, and out of those 3 watch Cops Are Kids. So let me mark this 13 over here. Let me mark this 3 over here. So basically what I can do is that, let me first jot down the detail because that's very, very necessary. Out of 30, there are 18 males and there are 12 females. And out of these 18 males, there are 13 who watch that TV show Cops Are Kids. And out of these 12, there are 3 who watch that particular TV show Cops Are Kids. Now, what exactly is the question asking? Let me just decrease the brightness a bit. And it says, find the probability that the person chosen at random from the group is either female or watches Cops Are Kids or both. Now remember that in class, when we were studying this particular chapter, there is this formula that I talk about and I label it the general probability formula. It is with reference to set notation and all these things. That is that probability of A or B, that is equals to probability of A plus probability of B minus probability of A intersection B, or I can write A and B. Remember, so let me just highlight things over here. This is about the general probability formula, which is derived from what you call, that is set notation, Venn diagram, all these things. So now over here, one thing that I want to focus on, that union means or, and means intersection. And this formula, what it says is that probability of two events, probability of A or B or both, that's probability of A plus probability of B minus probability of A and B. So A and B. Now they are talking about it's either female or watches cop circuits or both. So probability of female or the TV show cop circuits, that is probability of female plus probability of those watching cop circuits minus probability of both female and cop circuits. KK stands for cop circuits. So now over here, how many females are there? There are 12 females. So let me use a different color marker over here. There are 12 females. So that is 12 out of 30. And one thing that is my trademark, that I want you people not to reduce any fractions, just work with that. Probability of KK, that is how many people are watching this TV show, Cop Circuits, that is 13 plus 3, which is 16, that is 16 over 30. Now, what should we subtract? We should subtract those people who are female and watching Cop Circuits. So there are 3 females who are watching Cop Circuits. Because why are we subtracting it? We are subtracting it because these people have been counted as part of the female group. These people have been counted again once as part of the KK group, the Cop Circuits group. So that is why we subtracted once. Minus 3 over 30. So 12 plus 16 is 28. 28 minus 3, that comes out to be 25. So this is 25 over 30. At this point, if you want to reduce it, go ahead and reduce it. The answer is 5 over 6. Now, some people, they can ask this question, and we are going to do it, these questions. These are very, very comprehensive questions from the beginning of S1. And if you are very well versed in these questions, you are fit for your exam, whether it's your upcoming midterm, whether it's your CAI. So now the concept over here is, let's open up our minds. Someone can ask this question, sir, is it necessary that we use this formula? The answer is no, absolutely not. What we can do is that we can just pick these people from here. That is the 12 female, and out of these 12 female, there are 3 Cop Circuits. So now you can just choose these 13. So take this 12, take this 13, 12 and 13 is 25. So you can also do it like this. That means you are choosing male TV show people, the Cop Circuits people, and you are choosing female. That includes these 3 also. So there is nothing to subtract. That is another way of doing it. Now let me focus on the second part. The second part, it says, show your working, determine whether the events the person chosen as male, the person chosen watches Cop Circuits are independent or not. So this is part 1. Let me label it. This is part 1. That's done. Now we are focusing on part 2. Probability of male, I'll just calculate it. Probability of Cop Circuits, I'll calculate it. And then there is anyone who is both falling into the category of male and cops are kids. And then we will apply our independence equation. So now, first of all, how many males are there? There are 18 males. So this is 18 over 30. How many people watch cops are kids? So there are these 13, and these 3, that is 16. So 16 people watch cops are kids. Is there anyone who is falling in both the category? The answer is yes. There are 13 males who are watching Cops Are Kids. So that is 13 over 30. Now, what is the independence equation? The independence equation is this: if two events are independent, it is necessary that probability of A and B should equal probability of A into probability of B. So over here, if I say probability of male and KK, Kops circuits, if it's equal to probability of male into probability of Kops circuit, if it fulfills this equation, we will say the two events are independent. If it doesn't fulfill this equation, we will say the two events are not independent. So M and KK, that is 13 over 30. Now it's up to you people that you grab your calculator and do the calculation for me. And those people who have my WhatsApp, they can just message me so I can double check. 13 over 30, is it equal to probability of male, that is 18 over 30, and probability of female, KK, that is 16 over 30. Now multiply it out. And if it's equal, we will say it's independent. So I'm just waiting for you people to try it out. (18 into 16 over 900) and 13 over 30. Yes, you can use decimals. And I'll just go to my WhatsApp so that someone who has done this thing, they can let me know. Yes, I have the mark scheme. I can just open it up, but I want you people to try it out first. Okay, people, I'm waiting for it. Okay, one of the student has told me that these two are not equal, therefore the conclusion is not independent. So now, once you have done this, now it's time to go to the mark scheme, and that brings us to an examination point of view. And let me write it over here. So I'll be putting in some sticky notes over here for you to understand that. Try out the whole question, write all steps, then do the calculation, and at the very end, then check the answer. And only check the answer, not the methodology from the mark scheme. So now it's time to check the answer, and this is 5 over 6. I'll just highlight this answer. This is 5 over 6. That's answer of part 1. And for answer of part 2, it says not independent. All good, all clear. Let's move to the second question. So the first question is done. That was about the general formula. What is the second question all about? We will know once we have read this question completely. At a glance, it seems that this is about a table, and the info is given over there, and then plus something, and then plus something. So let's get started with that. So now we are focusing on this, that it says a box of biscuits contain 30 biscuits, some of which are wrapped in gold foil. Now, first of all, this thing is 30. And some of which are wrapped in gold foil and some of which are unwrapped. Some of the biscuits are chocolate covered. 12 biscuits are wrapped in gold foil. So this 12 over here, that is gold foil, that 12 should come over here. That is the first thing. That means over here, unwrapped should be what? So this unwrapped, let me just clear this thing, the small eraser and this thing over here. Therefore, the unwrapped should be 18, 30 minus 12, that comes out to be 18. That is the first thing. And of these biscuits, 7 are chocolate covered. Which biscuits are they talking about? The one wrapped in gold foil. Out of these, 7 are chocolate covered. Okay, I'll just move this. Okay, good. So 7 of them out of these 12 are chocolate covered. So let me write over here this thing, that is 7. Therefore, this thing is coming out to be 12 minus 7, which is 5. All good, all clear? There are 17 chocolate covered biscuits in total. So altogether, chocolate covered should be 17. That means 17 minus 7, this comes out to be 10. 18 minus 10, this comes out to be 8. So I hope it's all good, all clear, the way that I filled it up. One last thing is left. That is 30 minus 17, this is 13, and that could also have been double checked. 5 and 8, 13, 7 and 10, 17, 7 plus 5, 12, 10 plus 8, 18, altogether 30, this way and this way. Now the question is about, let me just reduce it. Okay. Now the question is about, find the probability that a biscuit is wrapped in gold foil. Okay. Now, first of all, let me highlight the things. A biscuit is selected at random from the box. Second part, find the probability the biscuit is wrapped in gold foil. That means total gold foil is 12 and it's out of 30, which can be written as 6 2s are, 6 5s are, so that's 2 over 5. That is the answer for the first part. Now these questions are easy. It's very easy to gain marks. It's very easy to lose marks. So be a little bit vigilant. A lot of people, they think that the denominator is 12. No, the denominator is not 12. Why? Because the biscuit is selected from the box. So the total number of biscuits is the denominator, of which 12 becomes the numerator. That is the first thing. The biscuit is returned to the box. That's perfectly good. An unwrapped biscuit is then selected at random from the box. Find the probability that the biscuit is chocolate covered. Now we are focusing on unwrapped. So technically, this second part, this is conditional probability. How is it conditional probability? Because now we are choosing an unwrapped biscuit. So unwrapped is how much? 18. So 18 is the denominator. It could have a chocolate cover. It could have not chocolate cover. But this time the biscuit is chocolate covered. So therefore, I'll pick this 10 and I'll write it up. All good, all clear? So 10 over 18, that is the answer. Now, we are again returning the biscuit to the box. A biscuit is then selected at random from the box. Part 4, find the probability the biscuit is unwrapped given that it is chocolate covered. So given it is chocolate covered, and now it's saying that given that it is chocolate covered. So again, it's conditional probability. So how many chocolate covered are there? That is 17. So this is 17. And find the probability biscuit is unwrapped. That is 10. So 10 over 17. So let's double check the answer for the first three parts. 12 over 30, 10 over 18, 10 over 17. 12 over 30, 10 over 18, 10 over 17. Again, lesson number 2. So lesson number 2 is, that is, let me write over here. Lesson number 2. Work in fractions. Do not reduce unless asked by examiner. If the examiner asks for reduction, simplification, then do it, otherwise don't. Why? Because fractions are exact. Fractions are exact, so no worries related to accuracy. And all these things that I'm pointing out, they are related to what the examiner is expecting from you. So question number 1 was filling in the table. Question part 2, part 3, part 4, this is done. Now let's look at the last part. The last part says the biscuit is returned to the box. Nasir then takes 4 biscuits without replacement from the box. Find the probability he takes exactly 2 wrapped biscuits. Now, first of all, this is part 4, actually part 5. Part 5, this is without replacement. So now I have 2 options of working it out. So let me either work it out in terms of probability. Of course, we have to calculate the probability. Basically, the concept of tree diagram. Or let me work it out using the concept of combination. So there are 2 ways of doing this. Now, first of all, how many wrapped biscuits are there? So first of all, wrapped biscuits are 12, unwrapped is 18. It says 2 wrapped, which automatically means exactly 2 unwrapped biscuits. Got the idea? Now, if I focus on this, I look at the denominator, there will be 4 fractions. 30, 29, 28, 27. And let me use some color. Red color for wrapped. So red color for wrapped. And let me use blue color for unwrapped. So wrapped is how many? Wrapped is 12. So this is 12, then 11. And unwrapped is 18, that is 18, and that is 17. All good? One last thing is left. That is the arrangement plus NPR. This is NCR, this is NPR. 4 factorial divided by 2 factorial, 2 factorial. This 2 factorial is for unwrapped. 2 factorial is for wrapped, because based upon the color, we are taking the possibilities, the 2 different designs. So 4 factorial is 24 divided by 4. That comes out to be, there are 6 ways of arranging them. So if you draw a tree diagram, there will be 6 ways of multiplying it. So therefore, that is the answer for this part. That is the first method. Let's move to the second method. That is, there are 12 unwrapped, 12 wrapped, and then there are 18 unwrapped. So if I select 2, that is 12C2 into 18C2. And if I divide by, without any restriction, that is 30C4. So this 2 is for the wrapped. So let me just highlight this. This 12C2, this is for the wrapped. 18C2, that is for unwrapped. And this is for without any restriction. And these 2 are the different methods of getting the answer. Of course, you can use a calculator and do the calculation. So let me just show you the working. So now the first working is this. This is method number 1. This method number 1 is 30, 29, 28, 27, then 12, 11, 18, 17. 4C2 has a value of 6. 4C2 is the same thing as 4 factorial over 2 factorial, 2 factorial. And over here is method number 2. This is method number 2. That is using permutation, 12C2, 18C2 divided in multiplication divided by 30C4, and that's the answer. So therefore, this is method number 1 and this is method number 2. So 2 beautiful ways of doing the same question. All good, all clear? Now this one, I would like you to first read it. I'm just going through the WhatsApp to see if there is anything that's happening. Someone asked this good question. Can we do it using binomial? The answer is nope. Let me add a thing. Binomial is not applicable. Why is not applicable? Because probability is not fixed. Why is the probability not fixed? Because this is without replacement. So that is a good question someone has asked. That is binomial. Just because it is of two types does not make it binomial. There are certain conditions that needs to be applied, and what those conditions are there, the probabilities are fixed. The number of trials are fixed. From two perspectives, you can only do rain, no rain, getting a hit, not getting a hit, getting the number 6, not getting the number 6, and so on. But over here, the probability is not fixed. All good, all clear. So now let's look at this question, which is about Jody tosses a biased coin and throws two fair tetrahedral die. So now that's a good question. First of all, Jody tosses a biased coin and then throws two fair tetrahedral die. So I'm just drawing two blue lines for that. The probability that the coin shows a head is 1/3. So over here, the coin shows a head is 1/3. Therefore, tail will be 2/3, obvious. Each of the dice has 4 faces. That's 1 and 2 and 3 and 4. They all have equal probabilities. Jody's score is calculated from the numbers on the faces that the dice land on. Numbers on the faces that the dice land on. Now, I have done this question a lot of times. But when I'm doing it in front of you, I'm reading it twice. So lesson number 3. That is that when you are doing a question, so let me write over here, lesson number 3. Read, reread, understand, highlight, jot down. Now, these steps are necessary. If someone thinks that they can skip these steps and get a good grade, I mean, that's not true. I can only say that. If the coin shows a head, now 2 options. If the coin shows a head, let me just highlight this. So if the coin shows a head, the 2 numbers from the dice are added together. And if the coin shows a tail, the 2 numbers from the dice are multiplied together. Find the probability that the coin shows a head given the Jody score is 8. Now this is for 5 marks, but it's a very, very comprehensive question. First of all, realize this fact that this is a conditional probability question. So that's the first thing given. That means this is conditional probability. Now realize the fact that what is the condition? The condition is the score is 8. Now, how can we get a score of 8? There are 2 options. Either we obtain it from the head or we obtain it from the tail. The probability of head is 1/3. Probability of head is 1/3. Probability of tail is 2/3. From the head, the 2 numbers are added together. So head, it's about addition, and this is about multiplication. When we talk about addition, how can we get an 8? So 4 and 4, that will give me 8. Multiplication, we need 8, so 2 and 4. So 2 and 4 is one option, and 4 and 2 is the other option. Now, when we are having this tetrahedral die, so probability of getting 4 is 1/4 into 1/4. Why? Because, or just 1/4 first of all. Let me write just 1/4, that's 1/4. Probability of 2 is also 1/4. That means 4, that means 1/4 into 1/4, that is 1/16. Over here, this 2 and 4, probability of 2 is also 1/4, 4 is also 1/4, that is 1/4 into 1/4, which is 1/16. 4/2 is also 1/4 into 1/4. Let me just remove this on the sidelines. That comes out to be 1/16. But don't forget probability of head. Don't forget probability of tail. So probability of getting a score of 8 is basically probability of head and then 4/4, or probability of tail and then 2, 4, or probability of tail and 4, 2. So basically taking care of everything. So this is the red one, that is 1/3 into 1/16. And these are the blue ones. This is blue, this is blue, this is red, again the blue. That is 2/3 into 1/16 plus 1/16. So I've added these two like this. Now if I add it up, this is 1/48 and this is 2 at the top. 2 into 2 is 4. That is 4/48, which comes out to be 5/48. That is the probability of scoring a head. All good? Now it says find the probability the coin shows a head. Okay, so let me just grab this page over here and let me draw a line over here. So probability, the condition, that is the score is 8. That is 1/48 plus 4/48. This is based upon the head. This is based upon the tail. And they are asking the coin shows a head. So let me just remove this thing. The coin shows a head. So that means 1/48 should go up. So this thing should go up. So 1/48. So therefore the working is 1/48 divided by 5/48, which is a beautiful answer. 1/48 into 48/5, which comes out to be 1/5. Again, fractions are beautiful. Fractions are exact. Leave the answer in terms of fraction. Let's double check. So that's how they have written. Head 4, 4, tail 2, 4, tail 4, 2. This is one thing, the red thing. Let me color it. So this and this, that's the red. This and this, that's the blue. This and this, that's the blue. So what I have done is that I have written 2/3 on the outside and 1/16, 1/16 on the inside. And this answer comes out to be 5/48. That goes down in the denominator. And what goes up in the numerator? The head. That is 1/48 goes up. The final answer is 1/5. All good, all clear. So let me label this thing. What exactly is this about? This is about, you can say, conditional probability. And this is about the concept of sample space. And all the things are mixed up when we talk about probability. Now let me go up over here. This was about table information. It was about conditional probability. It was about either the concept of probability and NPR. This was about NCR. So that's how we categorize these things. Let's move on. Now, a conceptual question. So just think about what we have studied for binomial, or not binomial, mutually exclusive and independent. Just bring it to your head. I'll be drawing 4 boxes, 2 boxes over here. Okay. So blue one. And another one, I need a pink one. Now over here, let me just highlight this. There are 2 things that we talk about. So let me talk about, in general terms, what exactly have we studied. So first of all, let me just make the marker more thinner. When we talk about mutually exclusive events, the examiner can also label it or just call it exclusive. Probability of A and B is 0. And when we talk about independent events, the rule is probability of A and B should equal, the and looks bad, A and B should equal probability of A multiplying with probability of B. Now, they have given us a symbolic kind of a case. We don't know what A is. We don't know what B is. We just have to deal with numbers. We don't have to think deep, except for the fact that we have to know our concepts in and out. Now, they have given us the following piece of info. That is, probability of A is 0.3. Now, this will maybe, probability of A is 0.3, probability of B is 0.8, probability of A intersection B is 0.4, state giving a reason in each case. And this is of June 2002. A very old question, but a very conceptual question. And they do ask this on and off. You have just seen it, how they have asked in the table question. In which the events A and B are the first thing, that is independent. The second thing, that is mutually exclusive. Now, the two answers are different. If I talk about mutually exclusive, second part, so I'll say probability of A intersection B is the same thing as probability of A and B. That is 0.4, since, let me just increase it. Since probability of A and B does not equal to 0, therefore, the two events A and B are not mutually exclusive. That is the symbol that I use. Got the idea? So MEX, mutually exclusive, it is necessary that it has to be 0. The intersection has to be 0. So let me highlight it. And let me add some color in it. Not this. All good. And over here, for independent, this multiplication equation should be there. So now, first of all, since P, A and B does not equal to 0, it does not fulfill this criteria. Therefore, the two events are not mutually exclusive. If I talk about the first part, now we have to apply this equation. Probability of A, probability of B, probability of A and B. Probability of A into probability of B, that is 0.3 into 0.8. 0.3 into 0.8. 8 threes are 24. 24 over 100, that is 0.24. Probability of A and B, A intersection B, that is 0. How much? 4. Since probability of A and B does not equal probability of A into probability of B, 0.4 does not equal 0.24. Therefore, what's the conclusion? The two events A and B are not independent. So over here, the condition was this thing. If it does not fulfill this criteria, it's not independent. If it fulfills this criteria, it's independent. All good, all clear? So that is question number 34. And all these questions are from our topical book that you use every day in class. Now, another one, another classic question. And let me just highlight this. And let me highlight this. This is basically on the idea of mutually exclusive and independent events. The next one, that is on the idea of what this is. Let me write it. It's common sense. Well, it's not that common. We all know that, but it's kind of counting options. You can say it is like sample space kind of thing. So now it says Ivan throws 3 fair dice. Now we have done questions related to 2 fair dice, and whether it's a tetrahedral die, which we have just seen, or it's a 6-phase die. So 4 into 4 are 16 possibilities, or 6 into 6, 36 possibilities. But over here, and then we would draw a sample space diagram. But when we are talking about 3 fair dice, and that's a normal 6-phase die, you cannot draw a sample space diagram. So that is the thing. So another lesson that comes over here, that is this, that over here for lesson number 4, maybe lesson number something, 04, 05, I'm not sure. That is when we want to draw a sample space diagram, we can do it for 2 dice or 2 coins or examples. These are some popular examples. Or dice and coin. So basically, we have the x-axis and we have the y-axis. So we have one thing like this, we have one thing like this. Or maybe something like this. So we have either dice 1 over here, and we have the dice 2 over here, and that is how we have all the possibilities that appear over here, and so on. All good? But if we are having 3 fair 6-faced, because they did not mention it, that means it is the normal dice. If we have 3 fair 6-face die, 1 die or 3 dice, that means sample space can't be drawn. Sample space diagram cannot be drawn, but there is no limitation on the thinking part. Now it says list all the possible scores. Let me start with the first part. That is, list all possible scores on the 3 dice, which gives a total score of 5, and hence show that the probability of Ivan obtaining a total score of 5 is 1 over 36. So let me get started with the first one. That is this. That is 3 fair dice. Dice 1 and dice 2 and dice 3. So the first thing is 6 into 6 into 6. That comes out to be 216. That is 6 cube, 216 possibilities. That means 216, this is our denominator. This is the number of all the possible outcomes. That's the first thing. I need a total score of 5. Now, how can I get a 5? Now, let me use 3 colors. So let me just remove this color from here so that this is not there. Let me choose 3 colors. Dice 1, dice 2, dice 3, and let me write down the options. So 1 and then 1 and then 1. I'm just writing it down, and then I'll ask you to think. And this is 1, 2, 3, 4, 5 and 6, and let me write one more. So I need the whole thing like this. Now, what are the different ways in which I can add these scores, a total of this thing? So we are talking about a total. So hold for a second. So we are talking about a total. Can I have 1, 1 and 3? What do you say? Yes, you can have it. But I can rearrange it. 1, 1, 3, 1, 3, 1 and 3, 1, 1. All good, all clear? So we know that if we have 3 objects of which 2 are identical, they can be arranged in 3 ways. A, A, B, A, B, A, B, A, A. So that's the same strategy over here. What is the other way of getting a 5? What about 2, 2, 1, 2, 1, 2, 1, 2, 2. So these are 6 options. 6 options out of 6 cube, which is 216. So probability of getting a score of 5, that is 6 out of 216. That comes out to be 1 over 36, and that is exactly the answer that is written over here. All got, all clear? So once you got the hang of it, so let me just copy it and move to the next page so that you can understand how to do the next part. Now I'll just pause for a few seconds, maybe like 20 seconds, and I would like you to think of all the possibilities of getting a score of 7. If you have your notebook and register and pen pencil ready, just write them down. Just write down all the possibilities the way that I've written it. It's not necessary to use the color. I'll just keep quiet for the next 20 seconds. Okay, I think 20 seconds are up. So I was just going through the messages for all the people. Thanks to all the people who have given me the answer for the previous questions. And it makes my life much easier. So let me get started with this one. Okay. Now find the probability of Ivan obtaining a total score of 7. So we know that the denominator will be 6 into 6 into 6, which is 216. And now I need a total score of 7. So let me write it down. Total of 7. So if I choose 511, that can be arranged in 3 ways. 511, 1, 5, 1, 1, 1, 5. No need to use the color. Think of some other thing. What about 4 plus 2 is 6, 6 plus 1 is 7. Yes, the next one. 1, 2, 4. That can be arranged in 6 ways. 1, 2, 4, 1, 4, 2, 2, 1, 4, 2, 4, 1, 4, 1, 2, 4, 2, 1. That is 6 ways. Think more. I need a total of 7. What about 3, 3, 1? What about 3, 3, 1, 3, 1, 3, 1, 3, 3? That is how many ways? 3 ways. When 2 are identical, they can be arranged in 3 ways. When all 3 are different, they can be arranged in 6 ways. That's the idea. Think of something else. I need a 7. So 5 is used. What about 2, 2, 3? 2, 2, 3, 2, 3, 2, 3, 2, 2. That is also 3 ways. So I think that's about it. That is 3. That is 3. That is 3. That is 9. 9 plus 6. That is 15. So probability of getting a total, let me write it correctly, total of 7, that is 9 out of 216. Sorry, not 9, 15 out of 216. That's 15 out of 216. 6 plus 3, 9 plus 3, 12 plus 3, 15. So the answer is 15 divided by 216. That is the answer. All good, all clear? Now let's look at this question. This is about conditional probability. So let me write over here. So this is conditional and this is with tree diagram. Now it's your choice whether you want to draw a tree diagram with or without, doesn't make a difference. So it's your choice. With, without, that's your choice. Now let's read the question first. The people living in 3 houses are classified as children, parents, or grandparents. The numbers living in each house is shown in the table below. So there are 3 houses. Let me add color to it. House number 1, house number 2, house number 3. And then there are these children. So let me highlight it. 4 children over here. And let me just use this. 4 children over here, 2 children over here, 1 children over here. And then over here, 1 parent, 2 parents, no parents. There are no parents over here. And then 2 grandparents. Let me change the color. 2 grandparents, 3 grandparent, 1 grandparent. So there is a house in which there are 0 parents also. Got the idea? So now all the people in all 3 houses meet for a party. Now I'm starting with this one. All the people in all 3 houses meet for a party One person at the party is chosen at random. Calculate the probability of choosing a grandparent. Now, this is just a basic question. How many family members are over here? 4 plus 1 plus 2. That is 7. 2 plus 2 plus 3. That is 7. 1 plus 1 plus 0. That is 2. 7 plus 7 is 14 plus 2 is 16. So the denominator is 16. And how many of them are grandparent? So grandparent is this blue color that I've used. So this is 1 grandparent, 2 grandparent, 3 grandparent, 1 grandparent. So 2 plus 3 is 5, 5 plus 1 is 6, 6 over 16. And this answer reduces to 3 over 8. Let's just double check this basic answer. That is 3 over 8. Now this is the next part that we are starting. It says a house is chosen at random. Then a person in that house is chosen at random using a tree diagram or otherwise. So I think I'll just focus on this otherwise. So conditional, and let me write over here with tree diagram. That is a possibility. Without tree diagram. That's your choice. So now let me highlight this thing. Now it says a house is chosen at random. How many houses are there? There are 3 houses. So therefore the probability is 1/3, 1/3, 1/3 because nothing else is mentioned. The person in that house is chosen at random using a tree diagram or otherwise. Calculate the probability that the person chosen is a grandparent. So I think I'll use the otherwise option. I don't need a tree diagram. So I'll just write part 2. This is house 1 and then grandparent, house 2 and then grandparent, house 3 and then grandparent. House 1, that is the red color house. That is this thing, house 1 and then house 2 and then house 3. And then we are choosing the grandparent. So this is 1/3. This is either this or this or this. Then again 1/3 into something. Then 1/3 into something. Now let me just erase the colors so that it's not getting too much mixed up. Okay, let me choose these colors also. So now over here, how many grandparents are there in the first one? So in this one, there are 2 grandparents. In this one, how many grandparents are there? 3. In this one, how many are there? 1. So 2 over 7. This answer is 2 over 7. That is 3 over 7. And 1/3 into 1 over 2. So therefore, this is 2 over 14. This is 2 over 21. So 2 over 21. This is 3 over 21. This is 1 over 6. Let's add it up. So 2 over 21. Let me show you the working. This is 1/3 into 2 over 7. This is 1/3 into 3 over 7. This is 1/3 into 1 over 2. The final answer is 17 over 42. Leave the answer in fractions. So this answer is 17 over 42. This is the probability of choosing a house and then a grandparent. So this is house and then choosing a grandparent. This is part number 2. Now part number 3, it's again a very famous question. Given that the person chosen by method 2, is a grandparent. That means the answer of part 2, that is the grandparent. This is the condition, and condition goes down in the denominator because the word given is there. Something has already occurred. So before I proceed any further, I'll just draw a line and I'll write down all these possibilities over there. 1/3 into 2 over 7. And this is 1/3 into 3 over 7. And this is 1/3 into 1 over 2. This is house 1, this is house 2, this is house 3. What exactly are they asking for now? they are asking us calculate the probability that there is also a parent living in the house. Now, people get confused. That should we calculate the probability of parent? The answer is no. Whatever is the condition goes down in the denominator. That is rule number one. So rule number one is that condition goes in denominator. And rule number two is something out of the condition goes up. So of course, it's not about the parent. It's about a house in which there is also a parent living. A parent is living, but we should write down the probability of grandparent at the top. So basically, this blue thing over here, this red thing, and this blue thing, and this is the green thing. So what goes up? This red goes up, this blue goes up, because that is house 1 and house 2. So this is 1/3 into 2/7. And this is 1/3 into, let me pull this nearer, this is 1/3 into 3/7. So therefore, we have 2/21 and 3/21. That is 5/21 at the top. The denominator is 17/42. So let's divide. This is 5/21 divided by 17/42. That is 42/17. So therefore, 21 ones are, 21 twos are. This comes out to be 10/17. Let's double check. And that is the answer for this particular part. Just have a good look at this question. So this is about the parent, and some people would be asking, which question is this? This is question number 38 from the topical book. The first part was basic, nothing to do with the rest of the question. That was just a filler question, just giving you some extra marks for free. The second part was that choosing a grandparent based upon the houses. House 1, grandparent. House 2, grandparent. House 3, grandparent. And then, given that the person chosen by method number 1 is a grandparent, so therefore condition goes down. So this is step number 1. So let me write over here, step number 1 was to take care of the denominator. Why? Because this is a conditional probability question. And step number 2, that is something relevant out of condition goes up. So this is house number 1 thing that's relevant, house number 2 thing that's relevant, and then it's all basic working, basic maths that's used over here. Now let's look at question number 44. Just read through it. Let me just have a look. Okay, now let's look at this question. The question says a box contains 300 discs of different colors. There are 100 pink. Let me highlight this. There are 100 pink color, 100 blue color, and 100 orange color. So I can use the color orange. And let me choose the other color that is over here. And let me use the proper pink color over here. So that is 100 pink, 100 blue, 100 orange. So the 3 colors, that is pink, and then there is the blue, and then there is this orange. So this is 100 of each. So this is 100, this is 100, this is 100. The disc of each colored are numbered from 0 till 99. So this is like 0, 1, 2, dot, 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 all the way till 99. And that goes all the way, 0, 1, 2, all the way till 99, 0, 1, 2, 3, all the way till 99. Now it says, this is with replacement. 5 discs are selected. Let me highlight this. 5 discs are selected at random, 1 at a time with replacement. So now you can consider about binomial if they ask from that perspective. The first one, find the probability that no orange discs are selected. So now the first part, let me focus on the first part. So this one, probability 0 orange. I can say X follows a binomial distribution. We are dealing with 5 discs, and the probability of orange, that's 100 out of 300. So that is 100 out of 300. So probability of orange is 100 over 300, which is 1 over 3. That's the first thing. Now, before I proceed, let me just copy this and take it to the next page so that I can write down similar things for the others. Now, the second part. It says find the probability that exactly 2 discs with numbers ending in 6 are selected. So 2 discs with numbers ending in 6 are selected. So now over here, we are interested in numbers ending in 6. How many numbers end in 6? It could be 6, it could be 16, it could be 26, 36, 46, 56, 66, 76, 86, 96, and that's it. It could be for all the 3 colors. It could be for pink, it could be for blue, it could be for orange. So let me write over here, it could be for pink, it could be for blue, it could be for orange. And how many numbers are over here? So we have these numbers, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 over here, 10 over here, 10 over here. Therefore, probability of numbers ending in 6, that is 30 over 300. And let me also write down the other part so that we can have everything ready and then we will work it out. That is this thing, the part 3. And what is part 3? The probability that exactly 2 orange discs with numbers ending in 6 are selected. So now it's a combination of orange and numbers ending with 6. So now this is only 10. So this is part 3. That is orange and ending in 6. So that is a very dark color for you to observe. So let me just erase this color and let me use a lighter color or no color at all. Okay, so now this is probability of numbers ending in 6 and we are talking about orange. So it's only 10 out of how many? 300. And part 4, let me also write down the definition of part 4. That is this thing. That is the mean and variance of the number of pink discs selected. So now we are talking about pink discs selected. So now how many pink are there? So pink is like 100. So probability of pink is 100 over 300. Now this question is a beautiful binomial probability question. Let me highlight this. So this is a beautiful, I just need to choose the color. So this is about binomial in all the parts. Why? Because this is with replacement. And in all 4 parts, there are fixed probabilities. Yes, the probabilities are different in all. For the first one, the probability of this thing, we are focusing on orange. So 100 over 300, that is success. For the last one, success is pink, 100 over 300. Over here, what is success? That is numbers ending in 6, that's 30 over 300. Over here, what is success? Success is numbers ending in 6, but only orange. That's 10 over 300. So I hope you realize what I am trying to emphasize on. That is, let me add a note over here. Another note, lesson number 5 maybe. So lesson number 5, that is, or lesson number 6, I think. Lesson number 6. Read and decide which case or scenario is applicable. Decide on the parameters, whether it's binomial. So we have n number of trials and p probability of success. We have geometric, that is number of trials is not there because it's infinite. So infinite number of trials, and the only parameter is probability of success. So now we can try this question out. The first one, we are looking for 0 orange. So probability of orange, that is this thing, 100 over 300, that's 1/3. And let me adjust my pencil, and let me just also check the thing. Okay, G. Let me just move on. So probability x is equals to 0. That is NC0, 5C0, success raised to power of 0, failure raised to power of 5, which is 2/3 raised to power of 5, and just use a calculator, or I think fractions will be exact. Fractions will be beautiful. So just leave the answer in fractions. The next part. Numbers ending in 6, exactly 2 disc. So probability x is equals to 2, that is 5C2. And this is success 30 over 300 raised to power of 2 and 270 over 300 raised to power of 3. Yes, you can simplify it further, 5C2. This is 27 over 30, which is 9 over 10, 30 over 300, that is 1 over 10. It has a power of 2, it has a power of 3. And of course, you can get the answer in decimals. Work in 4 significant figures so that the final answer is 3SF. So let me just highlight over here. Work in 4SF, final answer in 3SF. What about over here? Orange disc ending in 6. Again, it's asking for exactly 2 orange discs, and this is the probability of success. So now probability x is equals to 2, that is 5C2. Success is 1 over 30, failure is 29 over 30. It has a power of 2, it has a power of 3, and again the same rule is applicable. That is, first write down the answer to 4SF, final answer, that is 3SF. Last part, that is the mean and variance of the number of pink discs selected. Now, I hope everyone realizes that we are using binomial things. So let me just jot them down. X follows a binomial distribution with n comma p. Expectation of x is np. Variance of x is npq. And over here, probability x is equals to r, that is ncr. Success raised to power of r, failure raised to power of n minus r. So basically, in this part, we have used the formula. That is NCR, let me highlight it, NCR, success raised to power of R, failure raised to power of n minus R. The total probability, the total powers should add up to n. The total powers should add up to n, and let me write one other thing which I missed out. X follows a binomial distribution 5, 30 over 300. Over here, x follows a binomial distribution 5, 10 over 300. So we should always state this thing and then work it out. Last but not the least, expectation, and even before that, the binomial thing. So x follows a binomial distribution 5, 1 over 3. Expectation of x is np. So n is 5. P is 1/3, Q is 2/3. So that is 5 into 1/3. Just leave the answer as 5/3. Or if you are particular about fractions, that is 1 whole 2/3. Variance of x, that is NPQ. That is 5 into 1/3, which is 5/3 into 2/3. So that is 10 over 9, which can be written as 1 whole 1 over 9. So that is expectation and variance. Let's double check. 5 over 3, 10 over 9, all these probabilities are given over here. So the first one is that orange thing, that is 2/3 raised to power of 5, 32 over 243. That looks better. So 2 power 5 is 32, 3 power 5 is 243. Over here, this thing 4 significant and 3 significant. So the answer of part 2, that is over here, that is 5C2, success raised to power of 2, failure raised to power of 3. And this is the answer, 0.0729. So this final answer is 0.0729. Over here, this thing, that is orange ending in 6. 1 over 30 is the success power 2 because exactly 2 orange discs. 5C2, 29 over 30 raised to power of 3, 0.0100. So this is 0.0100. That is also 3 significant figures. The final answer, the final part has the answer that I have given in fractions. So I think, let me do this one because it just popped up. So now it says, again, this is like the conceptual thing kind of question. So this is like the mutually exclusive and independent type of question. So let's focus on this. So now it says 2 fair dice are thrown, 2 fair dice. Event A, part 1. The scores differ by 3 or more. Find the probability of event A. So A, score differ by 3 or more. 1 1, 1 2, 1 3, 1 4. 1 4 is the first one. And then 1 5 and then 1 6. All good. Write them in brackets. And then what about 2 1, 2 2, 2 3, 2 4, 2 5? This is 2 5 and 2 6. What about the 3 1? That is 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. And each one of them can be reversed. So I was working with 1 and 2s and 3, and now I can write 4 1. Now I can write 5 1. Now I can write 6 1. Now I can write 5 2. Now I can write 6 2. Now I can write 6 3. So basically, this is like this. This one over here, this is the 1 series. Let me make it smaller. This is 1 4, 1 5, 1 6. Then 2 5, 2 6. Then 3 6. Okay. And then over here, this is 4 1. And then this over here, that is 5 1. Let me change the color. That's 5 1 and 5 2. And then we have 6 1, 6 2, 6 3. How many options are there? That's 12 of them. So probability of A comes out to be 12 over 36. That's good. What is event B? So now let me just shift this thing a little bit over here. Score differ by 3 or more. Hold for a second. Let me just choose this thing. Over here. So this is event A. Second part, that is event B. It says the product of the score. So let me just choose a color. This is event A, this is event A, this is part 1, then event B, and now it's saying the product of the score is greater than 8. So now we are focusing on product is greater than 8. So if we talk about the 1 series, 1 into anything will not be greater than 8. What about 2? Yes, let me write 2 4, 2 5, and 2 6. And 3 2 3 3, 3 4, 3 5, and 3 6. And then let me write for 4. That is 4. It's greater than 8. Does not include 8. 4 3, 4 4, 4 5, 4 6. And then what else is there? 5 2, 5 3, 5 4, 5 5, 5 6. And then we have 6 2, 6 3, 6 4, 6 5, 6 6. Let's count how many are there. So now if I count from the perspective of 2, so I'll write over here, no, not this thing, that's black color, this thing blue, that is 2 4, 2 5, 2 6. And then the green color, That is 3, 3, 3, 4, 3, 5, 3, 6. And then the purple color for 4, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. And then the pink color, that's for 5, 5, 2, 5, 3, 5, 5, 5, 4, 5, 5, 5, 6. And last, that's 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So how many options do you see? We see these options 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Have I repeated anything? That's 2, 4 is 8. No, 2, 4 is not there. 2, 4 is not there because this is greater than 8. So this is greater than 8. So I think this is 20 options. Probability of B is 20 over 36. Let's double check. Probability of A, that is 12 over 36, all good. Probability of B, that's 20 over 36, all good. Now it says state with a reason whether the events are mutually exclusive. Now what is the definition? The definition of mutually exclusive is this thing, that for mutually exclusive events, probability of A and B should be 0. This is the only condition for mutually exclusive events, right? So now, is there anything in common? 2, 5, yes, there's one common. So just one is more than enough. So this is part 2. 2, 5 is part of event A. 2, 5 is part of event B. I don't need to look any further. Don't look any further. This is more than enough. So therefore, even if one is common, we know that probability of A and B does not equal to 0. Therefore, the conclusion is the two events are not mutually exclusive, period. And that is the answer. So there are 6 of them. I just picked one, and based upon that one, I can say there is nothing in common. If you want to pick the others, go ahead and pick it. So now we have 2, 5, we have 2, 5, and we have 2, 6. That's the second one. We have 3, 6. That's the third one. We have 4, 1, 5, 1, 6, 1, 5, and 2. That is this over here, 5 and 2. And then we have 6 and 2, that's right over here. We have 6 and 3, that's right over here. So how many are common? Yani 1 would be more than enough. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These are the common ones. So in reality, altogether, so instead of reality, just write altogether, there are 6 common options. So basically, probability of A and B is 6 over 36. And maybe they could have asked a question of independent, so you would use the independence equation, but they did not. So I think that was about S1, the probability review. And we came across a question of binomial also. We came across the tree diagram. We came across the table question. We came across conditional probability. We came across, I think there was this NCR thing also. And we came across this thing that was probability with NPR. And we also did a question in which the concept of what you call the table, I think that's I've already written. So that was used. And of course, the counting principle as in E1. So the counting concept is there. So I mean, this was a brief overview from my side. Hope that it will help you a lot in your upcoming midterm exam. So till the very next class, take care, stay tuned for more content, and that's about it. Take care, everyone.